Lesson 81, Solving Inequalities with Variables on Both Sides. On example 1, it wants us to solve and graph. Again, whenever we solve inequalities, we treat them exactly the same that we would treat an equation. The only thing that we have to remember is that whenever we multiply or divide by a negative, that we must always flip the sign. So I see that this is my inequality and I have x on both sides, so I want to bring this x over here. So I'm going to add x to both sides so that this will cancel. 4x plus x gives me 5x plus 1 is less than 11. Now I want to get x by itself, so I'm going to subtract 1 from both sides. I get 5x is less than 10, divide by 5. So x is less than 2. So my point is going to be at 2. There's no equal sign, so it's open. My variable is on the left, so when I change it to an arrow, it points to the left. And this is my graph. Final answer. Okay, same thing here. If I have variables on both sides, I need to get them on the same side. So since this one's the smaller one, I'm going to subtract it from both sides. Subtract 2x over 9 from both sides, which will cancel. So 4x minus 2x gives me 2x, and then the denominator stays the same because I'm dealing with fractions. Oops. Less than or equal to negative 5 over 18. So now we want to continue to get x by itself. So I'm going to subtract 3/18 from both sides. So those will cancel. I have 2x over 9 is less than or equal to negative 5 minus 3 is a negative 8 over 18, which I'm now going to multiply by the reciprocal to get x completely by itself. Whoops, I did that backwards, don't I? Over 2. So cancels, cancels. I'm left with x is less than or equal to 2 goes into 8 4 times, 9 goes into 18 2 times. So that's a negative 4 over 2, which is going to be a negative 2. This is my final answer. So my point's going to be at negative 2. It has the equal sign, so it is closed. When I change it to an arrow, it points to the left, and my variable's at the left, so I'm good to go. And that is my final answer. Same thing here. Before I do anything, I want to combine like terms on each side. So on the left side, I have 4z minus 8z. When I put those together, I get negative 4z plus 1. Has to be greater than. On this side, I have 3 and plus 4. So when I put those together, I get 7 minus 2z. So now I want to get my variables on the same side. So I'm going to add 2z to both sides. Okay, when I'm dealing with inequalities, I just generally move the right side to the left so that my variable's already on the left and I don't have to worry about switching it again. So I have 2z, negative 2z, excuse me, plus 1 is greater than 7. Subtract 1 from both sides. So I get negative 2z is greater than 6. Divide by negative 2 on both sides. Z is greater than negative 3. So now all I have to do is graph this. So negative 3 is the point that I'm talking about. There's no equal, so it's going to be open. When I change it to an arrow, it points to the right. So it goes like this. Final answer. On B, again, I want to simplify first. I'm going to distribute my 3. So 3 times 5k is 15k. Minus 3 times 4 is 12. Bring everything else straight down. Did I divide by a negative here? I did. Look at that. I just thought of that. I divided by a negative here and I forgot to flip my sign. So my sign, instead of this, should be this way, which means I should have shaded to the left. I'm so sorry. See, you have to be very careful of what you're doing so that you don't make that mistake. Go like that. Get rid of all that. Let's shade it the correct direction. Please excuse my mistake. I don't know why I just thought of it, but I did. So, all right, here I'm going to subtract 30k from both sides. So I have my variable on the same side to start with. So I get negative 15k minus 12 is less than or equal to 3. I'm going to add 12 to both sides. Okay. So when I do that, I have negative 15k is less than or equal to 15. Divide by negative 15. Remember, when I divide by that negative, my sign must flip. 15 divided by negative 15 is a negative 1. So my point that I'm talking about is at negative 1. It has the equal, so I'm going to shade it in. And then if I, since my variable is on the left, if I change my sign to an arrow, it points to the right, so I shade to the right. That's my final answer. On 3, it says determine whether each inequality is sometimes true, always true, or never true. If it is sometimes true, identify the solution set. So whenever I have this, I'm going to start by simplifying always. So I have 2x plus 2x gives me 4x plus 1 is greater than 4x plus 10. Okay, so at this point, I can get my variable on the same side, but I can also see so at this point, I can work to get my variable on the same side. So if I subtract 4x from both sides, what that gives me is that they both cancel out. So I get 1 is greater than 10. Is 1 ever going to be greater than 10? The answer to that is absolutely not. Okay. So this one is going to be never true. Okay, not true. And the next one, again, we're going to combine our like terms. So those would cancel out. So I get 3 is less than. Over here, those also cancel out. So is 3 less than 9? That is absolutely true. Okay, so to check it, if it's always true or sometimes true, let's put in a positive and a negative and see what happens. Okay, so if I put positive 1 in here, I would have 2 plus 3 minus 2 is less than negative 7 plus 9 plus 7. So that gives me 3 is less than 9. That's true. If I did a negative instead, I'd have negative 2 plus 3 plus 2 is less than 7 plus 9 minus 7. So whenever I do that, those two still cancel. 3 is less than. Those two still cancel. 9, always true. Okay, it says the table shows the average number of American Kennel Club AKC registered rounded to the nearest 100 for Bernese Mountain Dogs and Rottweilers. Okay, so this is our table. It says the breed, the 2006 registrations, and the average change from 2002 to 2006. If the trend continues, in which year will the number of registered Bernese Mountain Dogs be equal to or exceed the number of registered Rottweilers? So we have to create an inequality for this. So we can see that there are 37 Bernese Mountain Dogs in the first place. So I'm going to have, I didn't say 37, 3,700 plus, because it's an increase of 300, x, okay? And it says we want to know in which year will the number of Bernese Mountain Dogs be equal to or exceed. So greater than or equal to the 14,700 minus the change, which is negative 1,900x. So what I want you to do is I want you to solve that one on your own paper. And I hope that you've taken good notes. I will see you in class tomorrow. Have a good night.